Hello, I'm Aaron, and this is my Chapter 3 FRQ chess corrections. And for the first part, we're asked to indicate whether the apparent weight of the card is greater, less than, or equal to the apparent weight in this figure. And I said that the weight should be equal because the gravity has the same effect because they're at the same height. This is wrong because since the cart is going down from a higher point, it will have a higher velocity, and this will increase the centripetal force of our cart, and this means that it will have a normal force, and the apparent weight is equal to the normal force, so that means it will be greater. So for this part, I gave myself a 0 out of 3. From part B, we're asked to derive an equation for the apparent weight at point B, and for this one, I started with MEI equals MEF, and I plugged in MGH for equals to 1/2 MB squared plus the apparent weight, and I just solved for it, but this isn't right. And what we were supposed to do is start with MEI equals MEF, and then we could have plugged in MGH equals 1/2 MV squared, since there's only gravitational potential energy at this point and kinetic energy at this point. And we could solve for B, and we would get B equals square root of 2GH. To find our apparent weight, we could do a force diagram at point B. So we have normal force, and we have gravity going down, and we do F equals MA, and we do Fn minus Mg equals Ma. Now, since we know that we're moving in a circle, we could plug in the centripetal force for the Ma, and that means we would get mv squared over r. And then that means we could plug in the v, the velocity we found right here, square root of 2gh, we could plug that in here, and that means we get Fn minus mg equals m square root of 2gh squared over r. We can move this across, and we get Fn equals mg plus m. That cancels out, and we get 2gh over r. And then we could just factor out the mg, and we get Fn equals mg times 1 plus 2h over r. And that would be your equation for the apparent weight. And for part C, we have to justify how this equation derived is consistent or not consistent with our reasoning in part A. So since I said this part was equal, I ended up saying that the equation is not consistent. But if I were to have the right equation and the right idea for this, I could have said that this equation is consistent with our claim, because if we increase the height of our object, or where the cart starts, it will increase the numerator on this part, and this will increase our overall normal force, which is equal to our apparent weight. For this part, I gave myself a 0 out of 2. And for this part, I gave myself a 1 out of 2 for starting with the MEI equals MEF. And that's it.